Hello again, class. Okay, we're going to pick up where we left off. We left off on question number 8, and this number here was how much that uh, cubic this many cubic feet weighed. Um, it was that many gallons, 21,000 gallons, and 175,000 pounds. Okay, I'm going to erase that. I'm going to move on to the last two questions on that sheet. This is 9 and 10. Now we can use the Celsius and the Fahrenheit. So the question was, if C equals 114, find F. Okay, so we're looking for F. So F, right here, equals, and you can put whatever one works for you. The formula, I believe, is written like this. You can reverse it. Times, and what was it? If C equals 114, right? C is right here. Okay, let's do the math there. Be right with you. Okay, just got to get the time straight. Okay, let's multiply that out. So we get 1.8 times 114 equals 205. .2, impossible. C equals 114. Oh yeah, all right, excuse me. 114 through me. I'm thinking that's Fahrenheit, that's Celsius. Okay, that's above boiling. Okay, now here's something to remember. Don't forget this. I think you all remember that boiling is 212, right? We do need that for heat, right? You should be aware of that if you're going to do any heat. Celsius scale, it's 100 even is boiling. Okay, now this one, number 9, the C is 114, so it's above boiling. So it's going to be above 212 degrees Fahrenheit. Okay, so what we have is, if you multiply this out, you have 205 0.2 plus 32. So F equals 237.2 degrees. Sorry about that, just drew a blank for a minute. Okay, now in a heating system, will the water start boiling in the boiler at 212? The answer is no, because it's under pressure. Now there is a formula for where the water will boil depending on the pressure. The higher the pressure, the higher the boiling temperature, the boiling point, right? We'll say at 250, it would take 30 pounds of pressure, 30 psi. I'm making that number up, of course. But a boiler can actually operate at 212 or say 215 degrees as long as you got that pressure on it. And the pressure is always, the pressure reducer, if you look at the tag sometime, take a look next time you heat. I believe it says 12 to 15 pounds. But when you look on the boiler, it's usually around 15 to 20, somewhere around 17, 18 pounds is more typical. Why it's a little higher than the setting, I'm not sure. But that is adjustable. Now, once the pressure gets up to 30, the pressure reducer is defective, doesn't work. The pressure relief valve trips out at 30. And once it trips out, again, you guys have done a lot of heat, know this. You probably can't use that relief valve again. You probably have to put another one on. And if it tripped out at 30 pounds, it did its job, right? But don't just put another one on there without finding out what caused it to go to 30 pounds. Okay, in any case, this here is, this was number 9. And let's try number 10. Okay, number 10. We're switching over to the other formula. So number 10 is, if F equals 75, find C. All right, so we use this one. C equals F, which in this case is 75. All right, so 75 minus 32 looks like 43 divided by 1.8. It's like 23.88. Okay, Celsius. Now, when do you see that? I haven't looked in years, but I remember seeing it on bank signs. It would say, they give you the time, Fahrenheit temperature, Celsius. And remember what I told you, the only numbers that are not a fraction or decimal are 15 and 59. Okay? 15 Celsius is 59 Fahrenheit. That's what, in other words, if it was 59 degrees out, the bank sign would say 59 Fahrenheit and 15 Celsius. Same formula, but it's the only number where you can actually do that. So what you need to do, here's something you probably won't remember, but just in case you kind of lose it on the day of the test because you got so many other formulas in your head. Remember the 15 and the 59 and try a formula. And if it comes out, you put in 15 and it comes out 59, okay, that's the one to go to Fahrenheit when you look for Fahrenheit. Or if you put in 59, you come out with the 15, that's the one to go to Celsius. All right? That's how you can remember it. All right, now that is the end of the 10 questions I gave you last week. And this class, which we've already gotten into here a bit, will be the cleanup for questions 17 to 20 on page 101, chapter 4. All right, I think you all agree it was kind of a tough chapter. Don't get too hung up on any of that trigonometry, right? The sine and the cosine and all that. Don't worry about that stuff. We don't go that far on, that I'm aware of in math. Okay, so question 17. Let's take a look. A centimeter is how much bigger than a millimeter? Okay, centimeter is 10 times bigger than a millimeter. Okay? And the next one, and if you want to know where you find that, look on page, let's see, where is it? Actually, no, I didn't find that one. I had to figure that one out, but it's easy. A millimeter is 1,000, century, anything like that is 100. So you got 100 versus 1,000, so it's 10 times bigger. And remember, all the metric system, which I'm sure you're aware of, is much easier than our system, which is called, I looked it up online, it's like the English Imperial. We're the only country with Liberia and Myanmar, the old Burma, that still use the system that we use. Right, and it mentions that we're not anxious to change to metric, so you guys are probably going to be okay. However, they're throwing quite a bit of metric at us with this book on the license exam. Be aware of it, like the temperature. I know you'll see that, and some of this you might see, so this doesn't hurt. All right, question number 18. Convert the following U.S. customary measurements. That's what they're calling it, U.S. customary. All right, I've never heard that name, but makes sense. It's what we use here in the United States. Converting it over to metric. Okay, what I did here is I put my answer right in my teacher's book. I never did get the answer sheet for this book. So 18 inches equals 0.457 meters, which is a little less than half a meter, right? Now, half a yard would be 18 inches, and we know that a meter is more than a yard, so it's definitely in the ballpark, a little less than half. So the solution would be 18 times 0.0254. Now, I looked around for several minutes before it dawned on me that they didn't have that formula. So what I had to do was take centimeter and move the decimal over a couple of places. So if you look at centimeter formula, what I had to do was take the centimeter formula, 2.54, and go where's the 0.0254 to get that. All right, so you want to write that down, 0.0254 if you had trouble with it. Like I said, it threw me for a little while. It wasn't that hard. I just didn't see it. It wasn't jumping out at me. Okay, the second one, 4 feet equals how many meters? All right. It's a little, 4 feet is going to be over a meter. A meter is 3 feet and a couple inches. So this is going to be about a 1.25 meters. So let's see what that looks like. 4 times the formula they gave us on the previous page. 4 times 0.3048 equals 1.21 meters. Okay? Number C, or letter C. 10 inches equals 10 times 2.54. They look for centimeters. All right, that formula is there. That's that 2.54 I just referred to. 2.54. So it's 10 times 2.54, which you just moved the decimal. So that means it's 25.4 centimeters is 10 inches. Okay, next one. 453 cubic inches equals how many liters? All right, again, they have a formula on the previous page, and they mentioned going from cubic inches to liters. And I have 453 times 0.016 equals 7.24 liters. So in other words, if you had 7.24 liters, which is roughly 2 gallons, you would have 453 cubic inches. Okay. Now, if anybody came up with a different answer, obviously we're not going to see this until next week. Please let me know. Like I said, I don't have the answer key. Next one, 2.5 cubic feet equal how many liters? Again, they give you a formula. 2.5 times 28.32 equals 70.8 liters. Okay, remember now, that's cubic feet. All right, last one. 346 cubic feet equal how many cubic meters? All right, so you multiply 346 times the conversion factor for feet to meters is 0.028. Again, these are given, so I'm not spending a lot of time on them. And the answer is 9,688 cubic feet. Yeah, 9,688. Hey, hold on. It can't be right. Now, letter F, hold off. 0.028. I think I missed the decimal there. I'm going to have to check that one out. Oh, I'm sorry. 346 cubic feet equals how many cubic meters? It's 9. I'm sorry, not 9,000. It's 9. I'm getting a decimal mixed up with a comma. 9.688. Okay, 9.688 cubic meters would be 346 cubic feet. Okay, that's it for the volume and the measurements. Okay, then they're switching over to Celsius and Fahrenheit, which we'll do in just a minute. I just want to do something for my own benefit here. Let's say we took a cubic yard, 3 by 3 by 3. Three by 3 by 3. Okay, so you got 3 times 3 is 9 times 3 equals 27, right? Cubic feet. Okay, so if you had 10 cubic yards, it would equal 270 cubic feet. This particular problem was 346 cubic feet equals how many cubic meters? Now, meter is bigger than a cubic yard. All right, that sounds about right. It's 1070. If it was meters, it'd be larger. Okay, so it's in the ballpark. Just wanted to see how it worked out. But this here, now some of these problems here, I suspect that some of this detail in going back and forth to meters and cubic feet, I don't remember that in math. Not a bad idea that you get familiar with how to do it, but I wouldn't worry about memorizing those formulas going back and forth from meters to inches, all right, for the volume. Now, you're going to have all of you are going to have at least 3 more years, possibly 4 for some of you guys, tier 1. And you can do some more on the math. You just don't do as much of the actual classwork. It's more on you to do the problems. But I'm sure that your instructors will cover a lot of this here. But this here was a good math exercise, even if you don't use all of this math for your license. But now, the last 2 problems absolutely are part of your license exam, 19 and 20. Okay, so let's see what we got for those 2. All right, so we're done with the volume measurements. Let's go back to the Fahrenheit and the Celsius. Okay, question number 19. Question number 19 is, you've got 85 degrees Fahrenheit, 85 degrees Celsius. So what's the Fahrenheit going to be? All right, so that means you're looking for Fahrenheit. So what do we do? All right, let's put this one down. So we got 85 degrees Celsius. All right, this problem right up here. Now, I reverse these. Don't worry about it. It doesn't do anything. So you got 85 degree Celsius is going to be 85 times 1.8. Let's see how that looks. $153. F equals 185 degrees. Okay. It sounds like an answer to a previous one. No, I guess not. Okay. Also, remember that 185. What is that? It's very hot water. It's water coming off a boiler. Now, most of your heating systems are, remember what they're set for, 180, 200. Okay, I don't know if we're going to do any heat this year. Probably not. Probably not on time. And technically, the heat is not on your plumbing exam. However, most of the plumbing shops, especially the small guys, do plumbing and heating. It's always on the truck. Hot water heating. And most people know, most customers are aware that we don't do hot air. Some of you guys might have bosses that do hot air. I found that there's more guys now that do hot air than, say, 40, 50 years ago. But this much you're expected to know. All right, but the operating temperature on a boiler is usually between 180 and 200. Okay? The 185, remember what I said about baseboard. That's what baseboard is rated at. So you got 600 BTUs per foot at 185. Okay? Standard baseboard. High capacity, high cap, might be around 700, 800 BTUs per foot. You have to look it up. I don't know if there's a standard in the industry. I'm not aware of it, but it's a lot more output. Like 8 foot of high cap might equal 11 feet of regular baseboard. We use it like in kitchens. Okay, so you get 600 BTUs per foot. All right, nothing to do with the class. The class ended right here. The question ends here, but I'm just relating this number to something. And here it is. It's the actual temperature of baseboard. And this temperature here is cut in, cut out. When it gets below 180, it comes on. When it hits 200, it shuts off. So just like a well pump, it's always moving, right? It's cooling, it's warming, right? It's always moving. When the heat is on, it's cooling much faster because the baseboard is actually cooling the boiler. Now, can you change this number? Yeah, some guys go like 190, 210. My advice is don't do that. Go with the 180, 200. If there's a problem or if they add a room or there's a screw up in the calculations, you always got a little cushion and you can adjust the temperature. Now, the new boilers are much more efficient than the majority of them that I was more familiar with like years ago. There were some very efficient boilers, high efficiency, up around 90, 95%, but not that many. And there was always the problem with the condensate when you get over about 87%. In any case, keep that in mind. Cut in, cut out. Okay, that was number, let's see. That was letter A. And let's see, letter B is, let me look at the book here, 5 degrees Celsius. And let's see, I'm going to run out of, we're probably going to run out of time if I give you more than the answers. All right, let's just do this last one. I'll do the problem because it's the other formula. This is the C. So the second one in number 19, letter, let's see. Oh, no, this is another one. This is the same thing, so I'm not going to do it. Take that back. When I did my own, I did one of each. This one here, they actually do 3 in a row. So the second one is 5 degrees Celsius equals, I came up with 41 degrees. So remember, 5 degrees Celsius is above freezing, freezing being 0, but not much. And on the Fahrenheit scale, that would be 41. Okay, letter C is one I did not cover. This is a sneaky one. This is below 0 on the Celsius scale. So what do we got? Letter C. Gave you the Celsius, so we're looking for F. So F equals minus 10, right, times 1.8 plus 32. Okay, so it's 10 times 1.8. Okay, we can all do that. Just move the decimal this way. Okay, now I haven't talked negative numbers this year. Not my favorite thing. But I like to consider it like, not that I play cards much, which is just as well. But if you played a couple of hands of cards, you lost $18, you made 32. What'd you end up with? Well, let's see. That's going to be minus 18. So you can deduct 18 from 32, and you come up with plus 14. Okay? So now you're going to say, well, this is below 0 on the Celsius scale. That's right. But remember, Fahrenheit, this is below freezing also. All right, so minus 5. I'm sorry, minus 10. Letter C was 10. They gave you a break on that. They gave you a 10. All right, so minus 10. That was the problem, right here. Equals 14 on the Fahrenheit scale. Okay, don't let that minus stuff throw you. Okay? All right, that was letter C. Letter D. All right, they went back to an easy one. 46 degrees centigrade equals what on the Fahrenheit scale? Okay, that's going to be pretty high. Remember, 15 degrees on the centigrade scale was 59 degrees. So this is going to be pretty hot. So this was 46. All right, so the answer for this one is 114 degrees Fahrenheit. Okay, so letter D is 19D equals 114 degrees Fahrenheit. Okay, no minus. It was a pretty straightforward, pretty easy one. Use that formula. All right, the next one. Let's see, where are we here? Okay, now we're going the other way. Now we're going from Fahrenheit to Celsius. So we're going from larger to smaller. All right, this one here is 105 degrees Fahrenheit. About as hot as we've ever seen it around here. And what is that going to be? Okay, so C equals F. Minus 32 over 1.8. Okay, let's go through it. F in this case was 105. $73 over 1.8, so it's 40.5. Okay. There it is the work for that. Now, the rest of the problems on number 20 are done the same way. Okay, what I'm going to do is I'm going to, just so I don't run out of time, 3:54. Yeah, we will if I don't get hustling here. All right, I want to wrap this up. If that's the formula you're going to use for these next several problems. All right, the next one is 46 degrees Fahrenheit. 46 degrees Fahrenheit, 46 minus 32 over 1.8, and that comes up to, let me see, that's going to be 7 point. Fahrenheit. Okay, so 46 degrees Fahrenheit equals 7.77. That's the answer for letter B. Letter C. All right, now they get into the minus. I knew they would. All right, let's see what we got. Again, don't let the minus throw you. Unfortunately, it does pop up on exams too. So the question is minus 24 degrees Fahrenheit. So C equals minus 24 and then minus 32, right? Like this, over 1.8. All right, so what do we got there? Just add them up. 56 minus. You lost a bit of money, right? Two rounds of cards and you lost. So just add them up. 56 over 1.8. Equals 31. That one doesn't look right. Oh, minus 31. Get my equal sign mixed up with my answer there. Okay, so it's minus 31. Okay. You really got to have these two formulas down, right? You have no choice but to learn these two. All right, that was letter C. And letter D, they go back to, actually this one's a little sneaky. This one looks like it's above 0 because it's 12. It really isn't. We'll see. Okay. First hand, you made 12 bucks. Second hand, lost 32. So what do you got? I didn't write all this down, so let's see if this is going to work out. So it looks like 20 divided by 1.8. Okay, I'm going to check this one out because I actually skipped that one step there. 20. Yep, 11.1. Okay, the reason that this is below 0 and this one is 12 above 0 is because this is way below freezing. Right? This is what, 20 degrees below freezing. And when you divide it out, it's below 0 on the Celsius scale. The Celsius scale, remember, 0, C equals 0, F equals 32. Don't forget that, right? So you can go down to, in this case, what is it here? And the Fahrenheit is, we'll say, 12 degrees, what was it? 12 degrees, right? So this can be minus 11, that can be plus 12 because they're both way below freezing on their different scales. Okay, so don't let that throw you. All right, I know you guys are going to get used to this. You're going to start working, doing a lot of your own problems, right? Okay. All right. Let's see how we're doing for time. I think we're just about done. Okay, I did want to do a couple of things, some grab bag things that are unrelated to this, but unfortunately, the time has kind of run out. Got away, not so much got away from me, but we're just wrapping it up. Okay, a couple of names for tools. We all know what metric is and Celsius scale. That's all like one and the same. Metric scale. Now I looked it up, and in this book they called it the U.S. customary scale is what we use. And on the tools, you guys that have metric tools, and the others they are SAE, right? Um, and then the other name is the imperial system. I looked this one up online. Like I said, it's us, Myanmar, the old Burma over there, right next door to China, in Liberia, and that's it. Everybody else is on the metric scale. Okay, and hopefully, at least for your career, they don't switch over like they did for automotive. Okay, that's it. I will see you guys next Monday, and I'm going to ask Maureen to send you question sheet number 14. I believe it's the last question sheet in that series. I'll get some gas stuff that we can do later on, but we're getting also, I'll mention it in class, but in case I don't, we have, I believe, 4 more classes after this one. And I talked to my boss, again, if I forget to tell you, I talked to my boss the other night, but she was just like, she was at school and she was starting something and she couldn't really get into it with me. But I mentioned to her that about makeup, and she did not give me any answer at all because she had to, excuse me, she had to go. So I'm going to have to talk to her again. But again, unless I don't mention it tonight, please keep your attendance up. Most of you have pretty good attendance. All right, because at some point there's going to be somebody with a certain number of absences. There's just no way that you can make it all up. So please, if you got pretty good attendance, keep it. And I'll see you guys next Monday. Don't forget to do question sheet number 14. See you then.